So today we will discuss about the industrial application of Le Chatelier's principle. Okay, consider that we are in industry and we want to prepare, like we want to continue the process of Haber-Bosch process. Like you want to continue the Haber's process, right? And what is that actually? The basically Haber's process is the formation of ammonia, and we want the maximum production of ammonia. And so what kind of conditions according to the Le Chatelier we will give in order to get the basically maximum amount of the product, which is ammonia. For example, we have the equation which is N2 plus 3H2, and it is obviously a reversible reaction, and here we have NH3 here 2 plus some kind of heat is being produced. Now what will be the conditions? First of all, if you see the concentration, let's see the concentration, right? If we will increase the concentration of the reactant, so then we will get the maximum production. So here we will increase reactants. We will increase the reactants. We will increase N2, and we can also increase H2, right? Second condition in order to concentration we can give is that we can remove concentration of NH3. So the maximum amount of the reaction will combine together to form the NH3. So these are the both conditions for the concentration. Next we'll look into the pressure, right? Pressure. Okay, here if we talk about pressure, so here we have 4 volume and here we have 2 volume. So if we increase the pressure, so basically the reaction will turn towards the forward. So we will obviously increase the pressure, so the reaction can be proceeded in the forward direction. It will proceed to the forward direction. Now if we talk about the temperature, right? If we talk about temperature, let me write over here. If we have temperature over here, then for example, what is our reaction? Okay, we know that when we increase the temperature, right, so the reaction goes towards that side where it is endothermic, right? So I guess the reaction will, if we will lower the temperature, then this can be proceeded. So temperature must be low, because when the temperature is low, so the reaction will proceed towards that side where it is exothermic, right? So exothermic is towards the forward. So if we will give low temperature, then the reaction will proceed to the forward direction, right? Now if we talk about the catalyst, so here the catalyst that we will use for the maximum yield, that will be basically, if we talk about catalyst, that will be FeO2, ferrous oxide, right? Ferrous oxide will be the catalyst which will be used in order to give us the maximum yield in the minimum time, right? This is like basically the work of catalyst, right? So now if we talk about, this is how ammonia is made through the Haber's process, right? If we talk about, basically this Haber's process usually happens in the ice industries, right? In the ice industry, or you could say ice factory, right? Let's talk about another reaction which is contact process, right? If we talk about the second, which is contact process, in which we have the production of H2SO4, which is sulfuric acid, which is known as the king of the acids, right? So here we have like SO2 plus O2, they will give us SO3, right? Here we have 4, put 2, and here if we put 2, okay, this equation is now balanced. Now what kind of conditions we will give to get the maximum yield? So if we talk about concentration, we will increase the concentration of SO2, right? And we can also, like, basically we will increase the concentration of the reactants, and can also increase the concentration of O2. Another thing we can do is that we can remove the amount of SO3, remove SO3, so that the reaction can be proceeded towards the forward direction and the more maximum product can be formed. Now if we talk about, basically here heat is also released, heat also get released with exothermic reaction. So now if we talk about the temperature, basically if we know that when we increase the temperature, the reaction proceeds to that side where it is endothermic. So basically if we decrease the temperature, it will proceed to that side where it is exothermic. So we will decrease the temperature, or we can say will lower the temperature, so the reaction will proceed towards the forward direction, right? Now if we talk about the moles, we talk about the pressure. Here we have 3 moles and here we have 2 moles, right? So if we will increase the pressure, so the basically it will move towards when where there is low moles of, like, there are low moles. So here we will basically increase the pressure so that the reaction can proceed towards the forward direction. Forward direction, right? Now if we talk about the catalyst that we will use over here, will be the catalyst that we'll use over here will be vanadium pentoxide. It is very important MCQs as well. Mark this, I've seen in many papers as well. Vanadium pentoxide is a catalyst that is used in the Haber-Bosch process. So basically this is how the SO3 has been produced. Now SO3 will be dipped into the water in order to produce the H2SO4. So this is how, through contact process, your the king of acids, sulfuric acid, is being produced. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys.